Hello students, in this video we are going to study about chapter Gravitation class 9th. In the earlier video we have already discussed about universal law of gravitation and universal gravitational constant. The topics covered in this video will be free fall of an object, acceleration due to gravity, and relation between small g and capital G. Now, what is free fall? You can see the picture. The picture shows a freely falling of an object. That means an object, whether it is a heavy object or whether it is a light object, whether it is a living thing, whether it is a non-living thing. Whenever it is made to fall from a certain height, it experiences a free fall. Free fall means it will be freely under the effect of gravity. Okay, so free fall means that the object is under the effect of gravity. Is it clear? Now, free fall, the falling body which experience only one force, that is the gravitation of the earth, is known as freely falling body. Now, a freely falling body has acceleration equal to the acceleration due to gravity, because we have already studied whenever an object is in motion, it has acceleration. So, whenever an object is under the effect of free fall, it will have acceleration, and that acceleration will be due to gravity, okay, due to Earth's gravitational pull. That is your free fall. Now, if we set up an experiment in which a feather and a coin is taken, one is a light object and the other one is a heavy object, and a vacuum is created inside the jar, and both of them are allowed to fall at the same time. Now, what will happen? They will reach at the bottom at the same time. The reason being because there is no air resistance, there is vacuum. Okay, and another thing, both of them are experiencing the same amount of gravitational force, the same amount of acceleration due to gravity. Okay, so acceleration due to gravity, the acceleration with which a body falls towards the earth due to Earth's gravitational pull is an acceleration due to gravity, and it is always denoted by small g. Okay, we always write acceleration due to gravity with small g, and it is nothing else. It is the acceleration of a body with which it is moving towards the earth. Okay, every object is moving towards the earth, so that is denoted by your small g. Okay, so now we are going to study about the value of small g. The small g, that is acceleration due to gravity, is defined as the uniform acceleration produced in a freely falling body due to gravitational force of the earth, and it has a fixed value of 9.8 meters per second square. Okay, its value is fixed. Now, how this value came? This value came by using the main formula of universal gravitational constant, that is F is equal to G m into m upon r square, where m is the mass of earth and small m is the mass of the body. Okay, so after that, when you put the values of mass of earth and radius of earth and mass of the object, you get g is equal to 9.8 meter per second square. Now this g, that is gravitational acceleration due to gravity, it varies. Okay, first thing, it varies with altitude. Altitude means height. Okay, and it always decreases with height, but the decrease is very small. Like the journal value is taken as 9.8. So near the highest altitude, the value will be 9.76. So just a small decrease is there. Okay, then acceleration due to gravity decreases with depth. When you go deep inside the earth, okay, at that time also the height is decreasing, so the acceleration due to gravity also decreases. Okay, then what happens near the pole? Acceleration due to gravity is greater at the pole. Earth is slightly flattened at the poles and bulging at the equator. So the radius of the Earth at the pole is 21 kilometer, less than that of the equator. That's why it increases at the equator. But the increase is very less, okay? Otherwise, it remains same, that is 9.8 meters per second square. Now, when you have to use this g, acceleration due to gravity, in your equations, in your numericals, we have already done the 3 equations of motion. Now those 3 equations of motion changes to v is equal to u plus gt, h is equal to ut plus half gt square, v square is equal to u square plus 2gh. A here changes to g, that is acceleration due to gravity. Okay, so these are the things which we have to keep in mind when we are solving the numericals. Another thing which we have to keep in mind is your signs. How do we take the sign conventions? Like g is always taken as negative. Okay, g, acceleration due to gravity, is taken as negative. When a body is dropped from a certain height, its initial velocity will always be 0. When a body is thrown vertically upward, its final velocity will be 0. And the time taken by a body to raise to the highest point is equal to the time taken it to fall back to the same height. That means the time of ascent is equal to time of descent. So thank you all of you for watching this video. Hope you have understood the concept of acceleration due to gravity.